overview, we will be covering the evolution of grid computing with the public cloud. So in 2017, you and I actually sat down and we wrote a post on grid computing, specifically around infinitely scalable clusters. And it was kind of a 101 on grid computing. Can you walk us through how has the landscape changed since, I guess, Hentsu's inception and generally when we wrote that post back in 2017?
Yeah, so, I mean, it's still a huge topic, that's without doubt. If not even more so, data has definitely been the forefront of many firms and many technical challenges to use it, consume it, analyze it, process it, and so on. And it's increasing even more as progress is made in solving one challenge. There's always new ways of analyzing and pulling out answers that come up. So we definitely see it as a ever-evolving landscape and ever-increasing as well. But also at the same time, as it is becoming more widespread and accessible, barriers to entry are coming down, which obviously then opens up additional ways of processing data, managing it, adding more data on top. What we've also seen with this boom in alternative data sets are different ways of merging the data together, seeing the correlation come out, but also then finding the challenges or solving the challenges in managing these disparate data sets and process them to give reliable answers, because at the end of the day, it's the reliable answers that are key. So there's a growing need in both understanding the data, processing data, handling it, managing it, and also finding those answers out of it.
Yeah, that makes a lot of sense. And you mentioned the kind of evolving landscape, right? That's very true with technology in general. What's happening today can be irrelevant tomorrow, right? So a few of the technologies we spoke about in that article were MATLAB, Data Lab, BigQuery. Are these still relevant? Are they still in play? What new stuff are we seeing?
To an extent, I mean, there's always going to be some underlying tech, which is the foundations, the building blocks, as additional layers are added on top. What we are seeing though is a lot of the services coming out as a platform as a service, or even as a software as a service. So under the hood, they may be using some of the tech that's been around for a while, things like Hadoop, for example. But we're finding that platforms are building other iterations and flavors of tech on top of that, and opening it up to wider audiences, which are now seeing those barriers, as I mentioned, coming down. These tools that may have been quite CapEx heavy 5-10 years ago and very limited to the big pockets, the huge budgets, are now pennies to run up tests on a limited scales and just hundreds of dollars or thousands of dollars for some quite chunky workloads, which was unfathomable 5-10 years ago. So there is that evolution. There is still obviously MATLAB, albeit a lot of the kind of educational, the university kind of push is still relevant, and some of the legacy workloads are still in MATLAB. But there is a resurgence in the other kind of languages like Python and R, and then how those are then pushed through the various platforms that can handle them. The key thing that we see around the technologies, and that's somewhat kind of relevant to your first question around how it's evolved, is this serverless approach where there is no longer this notion of having these fixed servers that are handling the workloads. It is code that's distributed across ephemeral compute that just handles the analysis and then chucks out the answers without actually having to deal with what's the underlying compute infrastructure. So that's one fundamental shift that's happened in the last 2, 3, 4 years. This big push for serverless computing, obviously driven by things like Docker and how those can be leveraged into these ephemeral clusters that just scale up and down as needed, but also from the cloud platforms themselves that have these functions of service offerings. So both Amazon, Google, and Microsoft have ways of just chucking code at their platforms to do workloads and then come back with answers. And that makes things even more kind of scalable and fluid in terms of how they are deployed and scaled up and manage the compute.
Right. Now that evolution is really interesting. And you mentioned the platform as a service model, and that's something that was really born in the public cloud, right? So how have you seen the financial services generally kind of adopting that model? Because that's been really front and center since Hentsu's inception as well.
Definitely. And there is quite a push that we've seen from clients that are adopting a cloud strategy or cloud adoption strategy, which is putting PaaS first. And that has its pros and cons. The obvious pros that it's a very flexible, very quick entry into some very powerful tools without having to build a lot of the underlying foundations and building blocks around it just to get going. You can get going within a day or two. The downsides that need to be considered are things like platform lock-in, because obviously a platform as a service offered by a Microsoft will be different to the one offered by Amazon or Google, and the portability questions become quite important, whether it's a portability for technical reasons or portability for more business strategy reasons, and trying to figure out what balance do you have of lock-in versus functionality is probably key around choosing a platform as a service. But we see that quite prominently across a lot of our clients that are coming to us with that PaaS first, or being the kind of lead with PaaS, and then if you can't pick one of the other solutions. That is definitely putting the private cloud completely out of the picture. The traditional private cloud, because there is a bit of a hybrid that still has some place. But
why so? Can you actually talk through that a bit more on the?
Sure. So some of the cloud providers are basically offering an extension of their cloud back into the private data center. We've seen that both with Microsoft and AWS, and it allows you to run your workloads in your own premises as if they're part of the public cloud. So in that way, it's a bit of a hybrid, but it's not the traditional private cloud, because it's just an extension of that public cloud model, but it's sitting on your premises. Right. So it's giving you the same API, same functionality, but if you do want that data or that compute in your data center, you can still have it. Right. But I mean, that's very minor. We've only seen one client exploring that in the last 12 months. It's not something that's it's a big prominent ask.
I see. Yeah. So I mean, that answers a lot of questions on the platform side. The other interesting function is the infrastructure as a service, right? And I think we've seen more interest of that over time. How do you see that kind of matching to the demand for the platform as a service, and what are the differentiations? Why would you go one over the other?
Infrastructure as a service we've definitely seen as a kind of last resort. It's kind of considered as a lift and shift. And usually when options are constrained and it's some monolithic piece of software and it only runs on this type of a server, and there's no other option than just shoving it on a virtual machine in a cloud and managing as such. But it's but in terms of where the kind of the desire for the strategy and the push from the clients, it's pretty much the kind of last resort. If we can't do anything else, then let's just go infrastructure as a service. The kind of the obvious difference is that that level of managing is greater because you're getting into the operating system, you're getting into the actual virtual machine that needs to be managed, be secured, handled, upgraded, patched, all those things, scaled with demand, and it's an overhead that nobody really wants at the end of the day. And the kind of the past evolution is quite rapid in terms of what the platforms themselves are offering. That often it just doesn't even make sense to consider that infrastructure as a service. As always, back to my earlier caveats, you can manage those lock-in risks and kind of portability and so on.
Right, I see. And actually, you kind of mentioned the big players. That's, I think, a good one to touch on off the back of that is, Google, AWS, Azure. How have you seen those platforms evolve as well? And are they still, kind of all even? How do you make a decision for clients on, what platform they should be taking advantage of? And especially around the data, are you finding one stronger than the other, or do they all have their own kind of individual use cases?
Yeah, I mean, that's a really tough question. And we often get asked, coming into clients, well, which one would you pick, without even understanding what the underlying technical or the underlying business problem is, to come up with a technical solution. And as you say, it boils down to individual use cases. There is a lot of similarity between the three platforms, but there's a lot of nuances and differences. We have to consider what type of data, the type of processing workloads, the costs, the compute availability. It can come down even to specific GPU and CPU sets that we want to see utilized, maybe available in a limited fashion or not available at all in some platforms or in some regions. That can really steer the decision whether to go one or the other. So it's a tough question to answer on a general basis. We've seen Google traditionally be that huge big data kind of leader for many years. But both AWS and Azure have made huge strides in catching up. And those choices are easy. Well, they're tougher to make in some cases just because it is quite similar across the three platforms. And obviously there's a wider ecosystem question as well. Because the data may be one part of the solution, but what else do the firms have to consider, and what kind of workloads do they need to integrate that may help drive that decision towards one or the other cloud provider? We've also seen the mix and match. So the kind of the big data may be running on AWS or Google, but some of the corporate stuff may be on Azure. We've also seen the inverse, where some of the application development has been on AWS, but the big data has been on Azure with the corporate functions. So it is a bit of a mix and match, and I don't think any one of them is a kind of easy pick. Yeah, we'll just do this on this cloud provider.
But actually, you brought up a good point, the mobility between those platforms. So you mentioned earlier in the conversation, right, the serverless. So is that something that is really enabling, firms to be able to have that flexibility across testing multi-cloud cloud providers or setting up multi-cloud environments?
There are challenges with it. So yes, there is some mobility, but obviously if you're tied into a specific pass, then you're limiting yourself. There is mobility definitely when you're adopting that kind of Docker approach, and we've had a number of those solutions where we had to deploy kind of Kubernetes clusters across multiple cloud providers. So that's definitely a enabler to that mobility and enabler to that flexibility and freedom to pick where you want to run your workloads. One of the biggest challenges actually is that data handling, especially when it comes to massive data sets, terabytes and terabytes of data. Those are not easy to move around between cloud providers. That becomes a challenge and needs forethought where it will be located and what kind of compute can access it. Because once you shove hundreds of terabytes into one cloud provider, moving into another can be done, but you don't want to be doing that on a monthly basis.
So the planning is very, very important at this stage.
Yeah.
Right? Making sure that they understand what they're getting into before they make big decisions. That's valid. And did you have something else on that point?
And then it's figuring out also how your data lifecycle works, because you may adopt some kind of a tiering with a data lake in one type of setup, and then how you process it onwards built on top of that could potentially have some portability. But again, if you're getting into those hundreds of terabytes of data type of sizes, you really need to get it right ahead of time.
Yeah. A lot of planning. Okay, that makes sense. And kind of taking a different steer, we can't have this conversation in these times without bringing up COVID, right? And obviously the public cloud, I think it's been almost a seamless transition from what I've seen across the clients that I've dealt with as far as moving to more of a remote model. But looking at that remote working, how is that impacting things like research processes or workloads, or the way generally people are handling dispersed data sets and dispersed teams? Have you noticed that kind of evolution with such an abrupt switch to a remote working environment?
I mean, I'm not sure how directly relevant COVID is to kind of that data remote working, but it's definitely highlighted, especially with firms that have adopted that cloud approach first, that the work anywhere mentality for staff can work. I mean, there's nothing holding them back from adopting that approach.
From a technology standpoint, right?
From a technology standpoint. And that's also kind of highlighted that shift from processing on the desktop to processing the cloud services. And the firms that have taken up that the cloud approach, I'm not seeing any kind of impact on this remote working from the COVID impact. The downside has been some of the firms that still have the desktops as their grunt handling workloads. I mean, that is obviously a challenge.
Of course, yeah. Anything that's kind of touching on-prem at this stage.
It's a dying breed anyway, so I'm not sure how directly relevant it is, but it's obviously highlights those kind of benefits to it.
It just kind of accelerates a pivot that was likely to happen anyways, right?
Yeah.
Yeah, that makes sense. So, that's interesting. We've talked a lot about the broader landscape. I'd like to dive in a bit more to the Hentsu specific clients. Can you talk me through what data challenges you're seeing across the Hentsu clients and how we're aiming to solve them and how we're kind of tackling it?
Sure. And I think that can be split into actually two questions. So what is Hentsu doing with our own internal data and what we're doing for client solutions?
Yeah.
For our internal data, what's been quite encouraging and enabling is the adoption of some of the data science methodologies to some of the most mundane kind of workloads that we have internally. Everything from billing to kind of support and CRM and all the internal reporting. We've been able to adopt some of the high-end data science to get to the numbers and the analysis quicker and better. So that's something that we've seen rapidly grow within our own ecosystem and sphere of data, and manifest it through the BI and the dashboards and the reporting that can be driven off of the data warehousing that we can pull all these multiple streams of data into and then munge it in a far better fashion. And for client solutions, that really does come down to the individual data sets, how they're managing it, how they're processing and what they need to present it. Some of the interesting challenges with the kind of the breaking down of the barriers and the growth of the platforms and the data handling of them has actually created another problem in terms of, well, what do you pick? How do you make a choice? Comes back to, do you go to Amazon or Google or Microsoft as your platform? It becomes challenge to figure out that ahead of time, so you don't get stuck into a choice that's not necessarily the most viable one. So we've seen those kind of questions come to us and try to pick it apart and make those recommendations ahead of time so that it's a valid direction for the underlying challenge that you need to solve. The other one is obviously they're just the plethora of data, the ever-growing size and amount of data and diversity of data. So it's evolving that and trying to match with whatever alternative data sets might come up. How do we adapt that to being stored and analyzed in an efficient way as quickly as possible as these things come up? And that's probably also driven by firms that have traditionally not handled data science and had a tech heavy focus, adopting more of that tech.
The quantimentals.
The quantimentals, that's a classic one, but
I know.
Helping them navigate through those decisions when especially they don't have those internal capabilities themselves.
Right. And, you mentioned a lot this vendor lock-in. As kind of a last question to this segment, how would you guide clients on dipping their toe in the water, right? If they just want to test something or they just want to see what might be right for them, how would you suggest they approach that?
So we found that there is always a few internal projects which can be that pilot candidate for testing the water. It could be anything from some risk analysis, some portfolio analysis, or even the most mundane, financial data and analysis. So there will likely always be this good candidate that we can pick out of the challenges that the firms face and get them going with a pilot that kicks the tires across the platform and sees what they can pull out of it as benefits. And those don't necessarily need to be massively complicated or involved. We've done pilots in a matter of days or weeks, bigger pilots, a month or two, but it's a valid use case that can test how this could work and what benefits it can bring to the firms. So that step up is very small relative to how it was a few years back. There's no massive capex. There's no kind of massive spend that if it doesn't work out, you're not stuck with it. You can turn it off and choose another path.
Right. Okay, well, thank you, Marco. That was really, really helpful. Anything else you'd like to cover?
Nope,
we haven't touched on already?
It was a pleasure.
Thanks so much for your time.